Okay, so now let's do some examples of L'Hopital's rule. Okay? Let's say one of the classic ones is one that I already wrote up for y'all, but let's look at this. Now the limit as x tends towards 0 of sine of x divided by x. Okay? Now sine of 0 is 0. And well, if I plug 0 into x, it's just 0. So we say this guy is headed towards 0. This guy is also headed towards 0. I apply L'Hopital's rule. This would be the limit as x tends towards 0. The derivative of sine is cosine. And the derivative of x is just 1. And then we say that cosine of 0 is just 1, so this whole thing comes out to be just 1. That's it. All right. Let's try a polynomial one. So let's say we had the limit as x tends towards infinity of x squared plus 1 divided by x cubed plus 2x. Okay? So, both the top and the bottom of this problem that we're headed towards infinity. So, I could say, well, you know, this guy's headed towards infinity. This guy's headed towards infinity. Why don't I apply L'Hopital's rule? So that would be the limit as x tends towards infinity. The top would just become 2x. The bottom would become 3x squared plus 2. Now think about it. Well, okay, at this point in the problem, both the top and the bottom are still headed towards infinity. So I'm going to have to apply L'Hopital's rule for a second time. Okay? So that's headed towards infinity. That's headed towards infinity. I'm going to apply L'Hopital's rule. So that would be the limit as x tends towards infinity of 2 now divided by 6x. Okay, so now at this point of the problem, we've got to the point where this is a constant divided by infinity. And so if we have a constant that is divided by infinity, well, that's just going to equal 0. Okay. And today is just going to be a lot of examples of this. All of these problems do have a tendency to get harder as we go along. All right. So let's say we were having the limit as x tends towards 0 of sine of 4x divided by tangent of 5x. Okay. So sine of 0 is 0, and tangent is sine divided by cosine. So tangent of 0 is also going to be 0. So let's apply L'Hopital's rule to this limit. Okay. We say this tends towards 0. That tends towards 0. We can apply L'Hopital's rule. Okay, so the derivative of sine is going to be cosine. Okay. But remember, we're taking a derivative, so we also have to obey the chain rule. So it's going to spit out 4. Now, the derivative of tangent is secant squared. But that guy is also going to spit out a 5 from the chain rule. And then we can think about this problem. Well, cosine of 0 is 1, and secant is really just 1 divided by cosine. So secant of 0 is also going to be 1. So this is 1 times 4 divided by, well, 1 squared times 5, but we don't care about that. So this thing just comes out to 4 divided by, oh, there we go. Take it up a little bit. This becomes 4 divided by 5. Okay. So you can get indeterminate forms that go to 0, infinity, constants, a lot of different things, infinitely many different things. Okay. All right, another one. So let's say we had the limit as x tends towards infinity of e to the 3x now divided by, let's say, x cubed. Okay. So this is different from the limits that we were dealing with before because you can't divide by the highest power. So you have to have a way to evaluate this. And we're going to evaluate it using L'Hopital's rule, but we're going to have to use L'Hopital's rule several times. So I can say this is headed towards infinity. This is headed towards infinity. I'm going to apply L'Hopital's rule. And so that's going to be the limit as x tends towards infinity. This will be e to the 3x times 3. Then divided by 3x squared. Well, they're both still headed towards infinity. I'm ready to cancel those threes out, but I'm not going to, mainly for illustrative purposes. So this is headed towards infinity. This guy is also headed towards infinity. Let's apply the L'Hopital rule again. And so that would equal the limit as x tends towards infinity of e to the 3x. Okay, we're taking the derivative of e again. So what's going to happen is it's going to spit out another 3. So that's going to be times 3 squared divided by 3 times 2x. Okay, because we're just taking the derivative of x squared. Okay, you might wonder why I didn't just write it as 6. There's a reason for that, because when you get into later forms of calculus and you're taking multiple derivatives, normally you don't combine them together because you want to see a pattern that occurs within all of those derivatives. And so in calculus 2, whenever you're looking for the nth derivative, you don't start multiplying things together because then you can't ever figure out what the generic nth derivative is. But, well, e to the 3x is still tending towards infinity. X is still tending towards infinity. We're going to have to apply L'Hopital's rule again. Okay, so at this point in the problem, what do we have? E to the 3x is tending towards infinity, but the bottom is a constant. Okay? So now we have something that's headed towards infinity divided by a constant. So we just say, yeah, that is going to head towards infinity. Okay? And before I go on to some more difficult problems, let's look at some cases where you can't use L'Hopital's rule. Okay? Some people have a tendency to just use L'Hopital's rule as much as possible, even when they can't. Okay? So, let's say, let's isolate this. Let's say we have the limit as x tends towards 0 of e to the x divided by x squared. Okay. Some people would be tempted to try to use L'Hopital's rule on this problem, But you need to remember that L'Hopital's rule only works if the limit is of the form 0 divided by 0 or infinity divided by infinity, or if you can manipulate the problem to get it into that form. So with this problem, this is of the form okay, so if I said e to the 0, well, e to the 0 is really just 1. And then this guy is headed towards 0, so it is not the correct form, so we cannot use L'Hopital's rule on that problem. All right? Or, okay, let's say we have a limit as x tends towards infinity of e to the 1 divided by x divided by x. Okay. Well, e to the 1 divided by x. Remember, the limit as x tends towards infinity of 1 over x will tend towards 0. So this is e to the 0, which is still 1. And this guy is infinity. So this thing looks like 1 divided by infinity, which will go to 0. But we cannot use L'Hopital's rule. Okay? So you need to be careful whenever you're trying to apply L'Hopital's rule to these limits, because it has to be of the form 0 divided by 0 or infinity divided by infinity.